In this video, we're going to be making our transition from probability into statistics by introducing a concept called a random variable. And a random variable is a variable that assumes a numerical value associated with the random outcome of an experiment, where one and only one numerical value is assigned to each sample point. So to break that down, we have an experiment. And for our example, our experiment will just be a coin flip. And for that experiment, we have an outcome. And that outcome is what we're going to call our random variable. So our outcome is our random variable. And for this experiment, we're just going to say our random variable, or our outcome, is going to be x. So our coin flip is our experiment, and our outcome, our random variable, is x. And then for each of our sample points, so we have our sample points, and our sample points for our experiment, since we're doing a coin flip, are heads and tails. And from our definition of a random variable, we know that each of those sample points need to have some numerical value assigned to those sample points. So we're just going to assign them arbitrarily. We're going to assign heads to 1 and tails to 0. So now we have our sample points with numerical values associated with them. And now we have our full experiment, and we can talk about what a random variable is. So a random variable x can take on two possible outcomes. It can take on heads and it can take on tails from our experiment of a coin flip. And if we want to take this one step further, we can define the distribution of this experiment as, we can say, the probability that x is equal to 1. So the probability that we get a heads in our experiment is equal to, we'll say, 0.5. We'll just assume it's a fair coin, which means that our probability for x is equal to 0, which is x is a tail, so our coin flip is tails, is also equal to 0.5. And we'll call this our probability distribution, and we'll dig into that a little bit deeper as we go on. In statistics, we deal with two different types of random variables. The first is a discrete random variable, and the second is a continuous random variable. So for a discrete random variable is, by definition, a random variable that can assume a countable number, finite or infinite, of values. So we'll say discrete is countable. And it's generally mapped to the natural numbers, so can be mapped to the natural numbers. And the natural numbers are just the numbers that you'd use to count things. So these would be like 0, 1, 2, and so on, up to whatever number that we need, potentially infinity. Good examples of these are just counts of things. So we have counts, or like money, or anything else that has a discrete number of things. For a continuous random variable, these are, by definition, random variables that can assume values corresponding to any of the points contained in one or more intervals. So these random variables are uncountable. They can't be mapped to the natural numbers, so can't be mapped. And good examples of these are things like time, so the amount of time it takes to do something, the length of something, or the volume of something. So these are the two types of random variables that we have in statistics, and we're going to be digging further into these in later videos.